Welcome to Spaceverse, your portal to cosmic adventures. The truth is much more nuanced and much more interesting. Not long after the James Webb Space Telescope, or JWST, began its science operations, astronomers made headlines around the world. They claimed to have discovered galaxies so massive, so luminous, and so full of stars that they seemed far too advanced for their age. These galaxies appeared to exist when the universe was just a few 100 million years old, a time when the cosmos should have been dark, chaotic, and only beginning to form its very first stars. Naturally, sensational headlines followed. Articles shouted that JWST was breaking the Big Bang, rewriting cosmology, and forcing scientists to rethink the birth of the universe. But the truth, as always, is far more layered and far more fascinating than a few viral headlines. The Big Bang Theory has long stood as our most successful model of the universe's origin and evolution. It describes how everything began from a hot, dense state about 13.8 billion years ago, and how space itself has been expanding ever since. From this simple but powerful idea flows a wealth of observable evidence. The redshift of light from distant galaxies, the cosmic microwave background radiation left over from the universe's infancy, the distribution of light elements like hydrogen and helium, and the large-scale structure of galaxies we see today. The Big Bang Theory doesn't predict specific galaxies, it doesn't tell us which ones should exist or exactly where, but it does give us probabilities. It allows cosmologists to model how many small, medium, and large galaxies should populate a given patch of the cosmos at a certain time in its history. For decades, our telescopes could only peer so far back, catching galaxies a few 100 million to a billion years after the Big Bang. But the earliest, formative moments of galaxy creation, the cosmic dawn, remained hidden. That's where the James Webb Space Telescope comes in. Designed to see infrared light, the stretched-out glow of the earliest stars, JWST is humanity's most powerful time machine. It can peer farther back than any telescope before it, revealing galaxies as they existed mere hundreds of millions of years after the universe began. Then, in 2022, came a revelation that sent ripples through the scientific community. Astronomers announced that JWST had spotted galaxies whose redshift, a measure of how much the universe has expanded since their light left them, appeared to exceed 16. That corresponds to a time only 200 to 250 million years after the Big Bang. That's incredibly early, and these galaxies weren't just faint smudges. They looked mature, structured, even spiral-like, packed with stars and glowing brightly. To put it simply, they looked too developed for their age. It was as if you walked into a kindergarten classroom and found a group of fully grown teenagers sitting among toddlers. So what exactly was going on here? Were these galaxies evidence that the Big Bang Theory was crumbling? Was JWST revealing a flaw in the very foundation of cosmology? Well, not quite. Those bold headlines, as exciting as they sounded, left out an important detail: the method used to estimate those galaxies' distances. The initial measurements relied on a technique called photometry, which estimates redshift based on how bright a galaxy appears through various filters. It's quick, but it's also imprecise. To truly confirm how far away, and therefore how old, a galaxy is, astronomers need spectroscopic redshifts, which measure specific wavelengths of light. That's a much more accurate method, but it takes longer and requires more data. When those precise measurements finally came in a few months later, the picture changed dramatically. Some of the supposedly record-breaking galaxies turned out to be much closer than first thought. One famous example had its redshift revised from over 16 all the way down to 4.9, meaning it existed not 240 million years after the Big Bang, but over a billion years later. Suddenly, these impossible galaxies were, well, perfectly ordinary. The Big Bang Theory had not been overthrown. Cosmology, it turned out, was doing just fine, but the story doesn't end there. Alongside those reclassified galaxies, JWST did confirm others whose extreme distances held up under scrutiny. Among them is JADE's GSC 14-0, the most distant known galaxy to date, with a confirmed redshift of 14.32. This means its light began its journey toward us when the universe was just 290 million years old. Now that's genuinely incredible. But before you grab your Big Bang is broken sign again, remember this: astronomers expected to find galaxies this old. In fact, JWST was specifically built to look for them. Discovering galaxies like JADE's GSC 14-0 isn't a crisis for cosmology, it's a triumph. Still, the details of what JWST has revealed are intriguing. Jade's GSC 140 is small, only about 1,600 light-years across, compared to our Milky Way's 100,000, yet it's surprisingly bright and filled with stars. It's not enough to break the Big Bang, but it does raise interesting questions about how the first galaxies formed and evolved so quickly. Perhaps the first galaxies were more efficient at forming stars than we thought. Maybe early black holes, born from the collapse of the very first massive stars, played a role, using their immense gravity to pull in gas and trigger waves of star formation. Or it could be that the feedback from powerful supernova explosions actually helped fuel early star formation instead of suppressing it. Another possibility is that JWST's early surveys have been biased. Its instruments are sensitive to bright, compact galaxies, meaning we may be seeing only the most luminous, unusual examples. As the telescope gathers more data, we might discover a broader mix of fainter, more typical galaxies that fill in the cosmic picture and make everything fit neatly back into our models. And then there's the most tantalizing possibility of all, that we might need to add something new to our understanding of the cosmos. Maybe dark energy, the mysterious force accelerating the universe's expansion, behaves differently over time. Maybe it was stronger or weaker in the early universe, changing the pace at which galaxies could form. These aren't threats to science, they're opportunities. JWST isn't disproving the Big Bang. It's sharpening it, deepening it, and challenging us to refine our models. It's revealing the richness and complexity of a universe that refuses to be simple. That's how science works. The Big Bang Theory, like any scientific model, isn't sacred. It's a framework that has stood the test of evidence again and again, but it remains open to refinement. To say the Big Bang is wrong would be like saying evolution is wrong because we discovered a new species. The discovery doesn't invalidate the theory, it enriches it. And so, astronomers continue to peer deeper into cosmic history. With each new observation, JWST is painting a more detailed portrait of the universe's first few 100 million years. We're seeing the earliest bursts of starlight, the first galaxies flickering to life, and the delicate structures that would one day form clusters, superclusters, and vast cosmic webs stretching across billions of light years. What we are witnessing isn't the death of the Big Bang, it's its next chapter, a story of discovery, curiosity, and the relentless human drive to understand where we come from. So yes, the universe is full of surprises. Sometimes our data shakes up our expectations. Sometimes it humbles us. But every time it does, it reminds us that our cosmic story is still unfolding, one observation at a time. And as the James Webb Space Telescope continues to stare deeper into the abyss of time, who knows what other mysteries await? Perhaps it will uncover the seeds of the first black holes, or reveal the faint glow of population 3 stars, the very first stars ever to shine. Maybe it will find galaxies even earlier than Jade's GSC 140, pushing the frontier of cosmic history ever closer to the moment of creation itself. Whatever it finds, one thing is certain. The universe will keep surprising us, challenging us, and inspiring us to look up and wonder. Because even after 13.8 billion years, the cosmos still has stories left to tell, and we're just getting started in learning how to listen. So the next time you hear that a telescope has broken the Big Bang, remember, it's not breaking it, it's expanding it. The more we see, the more we learn, and the more beautifully complex our universe becomes. And that's the real magic of science. Every answer only opens the door to more questions. This is Spaceverse, where we journey through time, light, and the endless stories written in the stars. Stay curious and keep exploring the universe with us.